this video we are going to find dy dx of sine inverse of x. Say you are given y to be equal to sine inverse of x, then that means sine y will be equal to x. This is what it means. Now this also means, let's call this equation 1. Then let's differentiate this equation 1 implicitly. We are going to have cos y dy dx equal 1. Now let's take, please, I would like you to watch my video on implicit derivative to understand this very well. Now if we differentiate, if we make dy dx here the substitute formula, we are going to have 1 all over cos y, and let's call this equation 2. So from our trigonometry identity, we have that sine square y plus cos square y is equal to 1, and let's make cos y here the substitute formula. That means we are going to have cos square y to be equal to 1 minus sine square y, and that means cos y will be equal to square root of 1 minus sine square y, and let's call this equation 3. Let's call this equation 3. So let's substitute equation 3 into equation 2. That means dy dx will be equal to 1 all over, instead of putting cos y, now we are going to put square root of 1 minus sine square y. That also means dy dx will be equal to 1 all over square root. Now when we have sine, from equation 1 we have sine y to be equal to x. That also means that sine square y will be equal to x squared. So if we substitute that here, we are going to have 1 minus x squared. Instead of having sine square y, we are just going to have 1 minus x squared. So that means our dy over dx is equal to 1 all over square root of 1 minus x squared. It also means that d over dx, the sine inverse of x, is equal to 1 over square root of 1 minus x squared. Thank you for watching this video. Please, I would like you to like this video, subscribe to this YouTube channel, and hit the notification bell to get notified each time we upload a video. Thank you.